this is my explanation of my theories applied to a high-tech level of my invisibility holodeck technology theories. And I'll use my booklet's diagram to explain it. Somebody sent me a diagram similar to this so many years ago, and they were trying to figure out a way to send light through an object to make it appear invisible to the observer on the ground. And they had the idea of the 3D picture elements, right, that would encircle the entire surface of an object, and the light would have to meet up with a corresponding 3D picture element on the opposite side and be sent through as if the object wasn't there, as if the craft wasn't there. My solution, instead of having a complicated mess, my solution was to create what I call the light interface, and that's just the same shape of the object but in the concentrated form inside the object itself, and it has its 3D corresponding 3D pixels attached by fiber optic bundles to the corresponding 3D pixels on the light interface, and that shrinks the shape of the space that the object is taken up down to a more concentrated form where you can send light through the surface of the object, and it goes through the fiber optic bundles and goes through the light interface, which is just a hollow lenticular structure taking the same shape as the object you want to make invisible, and coming back out the fiber optic bundles to the sending or to the three-dimensional picture elements on the other side, and light would go through the object as if the object wasn't there, because you're imitating the space that the object is resting in, but in a concentrated form, and you're allowing light to go through as if the object wasn't there to stop it. And so it creates an interior light web on the inside of volume of this light interface. And this is just a three-dimensional view, three-dimensional perspective. The object that you desire to make invisible would have to have a simple surface like a stealth fighter, or a smooth, simple surface. It couldn't be anything complex like a car or truck because of the complex undercarriage and wheel wells and everything. But this is an image of an interface. It's the same diagram as the previous one, but it's a 3D perspective instead of a cross-section, and this is the interface within the outer surface of the invisible object, the craft. And this shows fiber optic bundles connecting the outer 3D pixels to their corresponding 3D pixels on the surface of the interface, the light interface, and together this creates an light interface system that combines 3D picture elements on the surface of the object, fiber optic bundles connecting those 3D picture elements with their corresponding position on the interface, and light going through and hitting a corresponding 3D pixel on the opposite side of the interface, going through another set of fiber optic bundles and coming out the bottom or the opposite side of the object all around. And as you can see, it's just a shrunken down volume of the shape that the object is taking up in space. So you're just concentrating the volume of the space that the object is resting in, so you can fit something in between the outer surface and the interface to make something invisible. And in my interface solution is my light interface concept is a solution to the problem of things with moving parts, like a battle suit, like the appendages of this battle suit. If you had a puppet interface, what I call a puppet interface, it just takes the same shape as the object you want to make invisible, like this battle suit, but in a more concentrated form, and fiber optic bundles, but are not shown, are connected to each of the corresponding parts between the outer 3D pixels of the object and the 3D pixels along the interface structure. and light is sent through, even if the object is moving, has moving parts, it maintains the path of the light coming in through the surface of the object, outer surface, to its point on the interface by way of fiber optic bundles. A light is shown through the interface and comes back out of the 3D picture elements on the opposite side, goes through another fiber optic bundle and comes out at the opposite side of the object. This is a more realistic vision of an invisible battlesuit of the future. Again, the 3D picture elements of the typical idea is one 3D picture element connected by a fiber optic wire to every other 3D picture element within its site, sending light through, but it's hardwired, and you couldn't have a thing with moving parts like a battlesuit hardwired, or else you'd have to change it every time it moved to match the light coming through at different angles, like the light coming through here and going through this wire and coming out here. Instead of having wires, you would have bundles, fiber optic bundles attached underneath each 3D picture element, and light would come in and through the bundles, through the 3D picture element on the surface to the 3D picture element on the interface, in this case the cross section of a cube, and light would shine through and hit the other 3D picture element at the opposite side of the light interface, go again through another set of fiber optic bundles, and back out the surface 3D picture element on the opposite side of the cube as a whole, or this cross section of this cube is a square. A square within a square is a light interface within the outer surface of the object, in this case a cube, or the cross section of a cube, a square. An invisible sphere, the ideal shape for an invisible object or a holodeck is a sphere, because light travels through it at regular intervals. Anything else has a different web pattern of light shine through the interface, but a sphere has a perfect three-dimensionality because light travels through it at regular intervals. Any other shape would have less 3D resolution, but you can increase the 3D resolution by increasing the number of fiber optic wires in each set of bundles connecting the outside 3D picture element to the inside 3D picture element of the interface. And all the interface is, again, is the same shape as the object you want to make invisible, or a holodeck, but in a concentrated form to allow something to exist in between the outer surface and the interface, being invisible to the outside world while imitating the path of light going through the space that the object's resting in. And here's what you can do. Here's a byproduct of the interface. The outside environment comes through at every angle, painting a three-dimensional picture all along the walls of the interface, so you could step inside the interface and you could view the outside world three-dimensionally like a holodeck. That's the inverse relation between invisibility and holodeck technology, is that the byproduct of sending light through an object to make it invisible also creates a painted three-dimensional imagery on the interior walls of the light interface that you can use as a holodeck of the outside surroundings, or you can play it back on a computer. This is another holodeck property where you can cast solid objects in the interface by taking one interface and feeding it of a solid object like furniture or a person, and feeding it in reverse to its other interface where you exist in, and there would appear like a solid object, like a piece of furniture or a person, appearing in the same room as you. That's another, I don't talk about that aspect very much. This is what you can do with two interfaces. You can have one making the object invisible and having another one that's in invisible holodeck mode, or in holodeck mode, interface converted holodeck mode, and you can have a computer or a recorded scene played in here in a virtual reality that you exist in while you're visually cut off from the outside world by having this interface connected with optic electronics to send light through the outer sphere in all directions, making it appear invisible. And this is a holodeck is like the interior of the lenticular box, but in a high-tech form. And the invisible sphere is an idealized version of a high-tech object being invisible. An invisible sphere is the ideal 3D resolution to make something invisible, and a sphere is the ideal shape that you want to make a holodeck out of. Even though in Star Trek it's usually like a square room or something with grids. In reality, a sphere is the preferred choice for a holodeck, or to make something invisible, because light travels through it at every interval. So you see the invisible aspect in a high-tech application going around the sphere, sending light through in all directions, and you see a holodeck aspect of the light interface converted to a holodeck, because you're sending light through in all directions inside the interface, and it's cut off from the outside world and the interface that connects the outside world to send light through. I don't know if I explained that well enough, but the last part of my booklet, I skipped the part about the lenticular box because I've done so many videos on it before, but the Rochester cloak, this is just a picture of the Rochester cloak, a diagram, schematic or something, where light is going through the 3D picture elements on the outside surface of a barrier and goes through what I would see here is like the light interface, my light interface concept, and the person is cloaked inside, and outside is the observer, just like this guy's the observer, and these are 3D picture elements on the front side and on the back side, taking an object and breaking it into light components and sending it through an interface. But to them it's probably a computer program, which they don't have any visual way to interpret it, so they just make a flash of light that connects the fiber optics coming in to the fiber optics coming out. But this is a recent advancement in invisibility technology, and it's called the Rochester cloak, and you can look it up on YouTube to see more of how it works. But I find that this is very similar to what I've had since the New Year winter of 1992, my light interface concept, and the whole concept of the light interface system in general, which a byproduct creates a holodeck on the interior walls of the light interface. And that's where invisibility and holodeck technology are inversely related on the high-tech level. I've already done videos of the lenticular box and explaining how invisibility and holodeck technologies are inversely related on a low-tech level, and this is just a high-tech application of my theories. Well, I guess that's about it. Thanks a lot.